Okay, we're back. We're going to 4.7, graphing linear function. Sorry about the length of the last video. In my videos, if I'm going slow, you can always times 2 speed. I figure that will shorten it down a little bit, make it more comfortable so you can finish. Okay, function model. Function model is f of x. Remember, function of x. Function of x is mx plus b. Look at that. What did we change? Well, remember, we have y equals mx plus b. So y is basically a function of x. So you could say the symbol f of x is read as the function. It isn't multiplication. So this is not multiplication. This is a function. What happens to x? Well, this is what happens to x, okay? That's what we're going to learn. So, we are graphing linear functions. So linear meaning line functions, okay? Well, first things first. Okay, we get a function, 3x minus 15, and they say solve it when x equals negative 3. So what do you do? Well, here we plug this into here. So we're going to say f of negative 3. Now f of negative 3 is going to equal 3 times, we're going to plug in negative 3 for x, times negative 3 minus 15. So 3 times negative 3 is going to equal negative 9 minus 15. So our answer is going to be negative 24. And so we're going to say f of negative 3 is negative 24. And that is going to be our answer. Now notice, this is not multiplication, okay? Don't change the order here, okay? With things on the right side, yes, that is multiplication, okay? Okay, so we'll keep going. Okay, similarly, if plugging it in, x in is possible, then you could plug in what f of x equals. This is also a true statement. So if f of x equals 2x minus 10, and I say f of x equals 6, then I can plug this 6 in for f of x and solve for x. Okay, do you see that? So if f of x equals a number, I can plug it in. Okay, so I plugged in 6 for f of x. And then I solve this. So I'm going to add 10 to both sides. I get 16 equals 2x. So then dividing by 2, we get 8 equals x. Okay, so this solid answer right there. Okay? Now, that is some basics of just plugging in and solving functions. The domain and range. So the domain for a linear function is going to be all real numbers. There's 3 ways of writing this. Okay, all real numbers. You can write it that way. You can write it with this symbol. Or, so it's a symbol, it looks like an R with an extra line through it. Or, you write it with parentheses. And because it's all real, it goes from negative infinity to positive infinity. Okay? So all 3 of these are true. Well, if the domain is all real numbers, what would be our range for a linear function? Well, let's ask the question. Okay, so this is for f of x equals mx. Is there any number that our function can't reach? Like if you if you tried to solve it for something, it wouldn't work. Like, let's use an example. Let's say f of x equals 2x plus 1. Is there any number that you can't plug into x? Well, no, every number can work. Is there any number that we can't solve for if we solve for it? And the answer is, there's no number that you cannot solve for. So, this would be all real numbers. Or a better way of saying this, all numbers work. There's no number. This is, okay, what's range? Range is what? F of x can equal, okay? Domain is what x equals, okay? So range is what f of x equals. Domain is what x equals. So this is all real numbers. And then this is the same. So for linear equations, we know what our range is, okay? Okay, that's domain and range. Now, key idea is parent functions and families of functions. So we're going to just briefly read this, and then we're going to go back to the notes. So, parent functions. Sorry about that. Okay. So, family of functions is a group of functions with similar characteristics. The best way of saying it is that they share the most basic fundamental characteristics with each other. That is, they have the same kind of domain and range. They have the same principles applied to them. So, f of x equals mx plus b is considered to constitute the family of linear equations. So think of your family. You should all have similar traits or similar characteristics. That's kind of what makes a family. Now, a parent is where it flows from, right? Your parents are where you come from, so parent linear function is where all the functions come from. What's the parent linear function? F of x equals x. What's its slope? Its slope is 1. What is its y-intercept? Its y-intercept is 0. That is the parent function. The parent function is parent linear function is the basic. Everything else builds off of that. Either adds something, subtracts something, or multiplies by something. Okay? That is the parent linear function. Okay, so if we compared graphs, now we're not going to go into detail here about comparing graphs, but notice, sorry. Why did I show you this before we get to this? Okay, notice in this first example, x plus 3, right? Well, what x plus 3, what's crucial there? Well, we added 3, right? So if you look at this, this is 3 more than the y-intercept, okay? Now, let's just say we don't need to worry about this. This is same slopes that are parallel. We're not going to do comparing graphs here because this is not built well, okay? So we won't be as worried about it, okay? But just notice, what did we do here? We multiplied by 2, okay? So our slope changed. Okay? So this is a vertical translation, is to add something, and to multiply something is a stretch or a shrink. So if it is, and honestly, don't worry about it. This, you know what? I'll let you guys think about this. This is not crucial for today, but it is crucial for later. So graphs have different positive slopes, but the same y-intercept. Graphs families are vertical stretches or shrinks. Okay, right? If the slope goes higher like this, red, it is a stretch. If it goes lower, it is a shrink. Okay, this is called a reflection. Okay, and then if it's different slopes, it stretches or shrinks. Okay. And then there's one more word problem. Basically, can you solve a word problem? It's the question. And I believe you can. You can solve the word problem if you need to. Okay, they ask you how they relate. So let's just say we're not going to do that one. We will do it for chapter 5. So, brief overview of stretches, shrinks, and vertical shift. So, our parent function is what? F of x equals x. Okay, translations. Translation has the same slope, but what changed? We added something, okay? So fx equals x plus b, right? Some letter, either some number, positive or negative. That's a translation. Positive is translation up, negative translation down. Okay, stretches. Is where our slope is a positive number, but it's larger than 1. Larger than 1. Okay? Or if you wanted to be super technical, it's when the absolute value is greater than 1. Okay, what about shrinks? Shrinks are going to be where our slope is a fraction. Okay, a shrink is going to have a fraction as a slope. It's the best way to kind of give it for now. Okay, something like that. Where it's some number between 0 and 1. So it can be a decimal fraction, but it has to be between 0 and 1. And then reflection is where we have our mx, but m is less than 0. Okay, so m is less than 0. So it's some negative number, okay? That's going to be a reflection, okay? Okay, thank you guys for joining us. I'll see you in class today. Bye.